We are going to be going through activity 02.01, so activity 2, for electrical measurements and instruments. For this activity, we will need a digital multimeter, which you can see here. You need a small lamp bulb like this, a little lamp bulb socket here, battery holder plus 2 batteries, as well as an optional thing. And there's also part of the end of the activity it has the option of doing some additional measurements with an adjustable DC power supply. Now, I don't have one at my station right here at the moment. So the very first thing that this activity says to do is familiar yourself with the multimeter, which I think Jill did a very good job going through this in the previous lecture. But I wanted to also show you a couple of the other kinds of multimeters before we got into it. So I brought up my a Fluke multimeter here from the electronics shop. 2 different kinds of them. Just so that you can see the different variations there are. These are actually auto ranging, so that you don't have to, select the individual ranges. They'll do it automatically for you. Very useful, but the difference is they cost more money. So if you ever so choose, well, if you want to spend money, you can always get a nicer multimeter. I'm actually going to stick with my Fluke multimeter here because I don't like dealing with all of the ranging, but that is part of what you will have to do as we go through this activity. And actually, the second step here is actually determine if your multimeter is auto ranging or not. If you guys all received the little red multimeter from your professor, you should note that this isn't an auto ranging one at all. The first thing you want to do is open up your miscellaneous parts kits, and that's where actually you will find most of the parts that you need for this activity. That's where the light bulb is, plus lamp bulb socket and all of that. And I know some of you don't have all of your parts yet. If you don't, just hang tight, just listen. You'll probably want to go back through this recording as we're going through it later on. But you'll want to put get the little lamp bulb, and you will want to measure the resistance of this lamp bulb as it just sits here on the table. And you can do that by the little bulb at the bottom here, putting 1 lead in there. It's kind of hard to do it, a bit of a pain in the butt, but if you hold it there, you should be able to, if I actually put it on resistance, measure it. And I'm not really receiving much. Let me try it with just measuring it across here.
Really? Use that multimeter.
Wait, no. I made the classic mistake. I had it measuring current, but not. I was in the wrong spot. Good reason.
So is this do what I tell you, Josh?
Yes.
Do what I tell you, not what I say. But you can see here, the number is bouncing around a little bit, and it's right around 4 ohms, roughly. So the resistance of your bulb is about 4 ohms right now, but there's no current going through it. Then I also find it easier, actually measuring it in the lamp bulb socket itself. The next step is to connect it together with the battery. So you want to put your batteries into your battery socket itself. One thing that is very useful to have is some alligator clips, such as these. And you will want to clip here. And clip here. I typically always connect ground first. And if you're using these lamp bulb sockets, you can actually unscrew these screws just ever so slightly. And you should be able to actually just grab onto them with the alligator clips. One of the things that is very useful to do is to make sure, because often if you're doing a lot of these experiments with alligator clips, it's going to become a literal rat's nest very quickly. And you can, any of these little metal bits touched, you'll get a short. It's not nice. So what you can do is just kind of wrap them up a bit. I'm actually going to unplug this so I can make it a bit neater.
You have your alligator clips around here?
They are right over there. There you are. So you can. Wrap it like this just so that it's not small. And then you can put, whenever you plug in the battery, you should be able to see that it glows a little bit. Not super bright, but it glows. And then you will want to change your multimeter into measuring the voltage. Sure, I'm reading that right. Yep. And from there, you want to measure across the two terminals. Now, there's actually two ways that you can measure this. You could put the black lead on black and the red on red, and you'll get a measurement, which here you'll see is about 3.1 volts. That is what we would expect here because each of these batteries, these AA's, have a nominal voltage of 1.5 volts. Now, actual batteries will always be a bit higher than the nominal voltage. These should actually be about 1.6 or a little around there. So that's about correct what we should expect. And I was using these batteries earlier just to make sure that everything worked right. But if you end up measuring it backwards here, you'll see it's now negative 3 volts. And that's just because I'm measuring the polarity backwards. And that's fine in most cases. So in that case, we got 2.9 volts measuring it backwards, 3.1. Right around, it should be around 3 volts. And you should write that number down somewhere. Next, you'll want to disconnect the lamp bulb. This thing keeps on twisting. Do you have that tape again?
Yeah.
I want to tape this down so my lamp bulb will stop moving. Thank you very much. Just so that it will stop tumbling. Now, the next thing you will want to do is actually try to measure the current going through this lamp bulb. So you will want to change your multimeter into the amp mode. And depending on the multimeter, like this particular multimeter here, you actually have to change lead over here to measure amperage. But in other multimeters, like the one that you have here, you'll see it measures milliamps there, so you may not have to change it at all in that case. I do in mine. And then what you'll want to do here is you will want to connect it in series with your line here. And so whenever you can touch it here, it should light up. And you should see that the current reads less than 200 milliamps. In this case, I'm measuring 118 milliamps. And you will want to write that number down. Because the next step in here is actually to calculate what the resistance of this light bulb. Yeah, that is, that is. Can you hand me that pen right there?
Yeah.
So you will want to calculate it. And so the resistance, if you recall from the lecture here, the Ohm's law is V equals I R. So the voltage is equal to IR and stuff like that. And what we want to do is we want to measure the resistance here. So you can rewrite this equation very easily just by dividing R, so you have V divided by I. And so our voltage was about 3.1 volts, and our amperage was about 0.118. And you can calculate what that resistance is. I don't have my calculator on here for me right now. And so you'll get that in ohms. And that was what your resistance will be. 1 second as I calculate this. And so it actually ends up being 26.27 ohms roughly. So 20, oh man, writing this backwards. Yeah, that screen sucks. So 26
No, the
ohms.
image is backwards.
Yeah, but you'll notice that's significantly, well, decently higher than the 4 ohms we measured earlier. But the only thing that's changed is the amount of voltage we're going through, that we're applying to it. But in this case right here, we weren't applying any voltage. Afterwards, we are, and that is about what you should expect. That as you apply more voltage, you should see more current. But the resistance changed. Sorry, stumbling over my words there. But what's interesting is this isn't a linear progression. Like if you ever see like a resistor, it will go just as you increase voltage, the current going through it will increase linearly. But with a light bulb, it actually does something like this, where it curves and reaches some peak resistance value here. And that's what a lot of the remaining of the activity is, where you go with a power supply, you actually apply different voltages to this lamp bulb, and you measure what that resistance should be at each of these steps. Now, I'm not going to actually step it through here and there, but whenever you get the activity, I highly encourage you to do that. And I would love to see all of your graphs of plotting out what that resistance value changes over time. But yeah, that's the very basics of what this activity is. If you have any questions, please don't hesitate to ask.
Do we need to go through a power supply now that operating?
Probably should.
Okay, we're gonna get a power supply just to go over the basics of that.
For those who haven't used a power supply before, this is one that we have here. It is rather simple to use one of these. This is an adjustable one. I need some banana ones as well. As you can see here on this particular kind, there's one knob that will adjust the current, the maximum amount of current that you can pass through, and one knob that will change the maximum amount of voltage, the actual voltage level you see through here. You'll have two screens. One will be displaying the voltage. One will display the current going through. Not all power supplies are built the same. You will see some many variations in the market. It really depends on what you're able to get. I will get back to this in a moment whenever we get some banana plugs to plug into our outlets down here, which is, by the way, where the power comes out. So this will be ground with black, and then red over here will be power, which will be the voltage that is displayed on the screen. Sorry, you guys couldn't see that. Black down here is ground, and red over here will be power, where the voltage that you see in the screen up here will come out. That's
I
fine.
got one, but
One's good. Possibly. No, I can't help this.
well, this is.
If there's just two red ones, that will be fine
yeah,
too. Alright. Unfortunately, I don't have multiple colors right now, so I will be using two red leads to measure for both my ground and my power. This is another case of the do what I say, don't do what I do. You should, whenever possible, color code and use black on black so that you don't mix these up, because it is incredibly easy if you're using the same colors to mix things up. So in this case, you plug your power supplies in here. Sometimes you'll be able to actually get away with using alligator clips. But this particular kind of plug requires a banana plug jack to go in. And from there, you just connect it all the same. Put on there, darn you. Testy little fella. All right, I'll have to do it like this for the moment. So I turned it on here, and you can see that the top voltage here is currently set to 0. The bottom here is set to -0.5. Interesting. Is this one working?
That might be it.
Oh, there we go. The current was just set too low. All right. So one good case there is if your current supply is set too low, you may see a negative voltage here. You always have to. You might have you have to increase your current supply just so that you don't get any current until you measure it. But if you don't have the current supply set up high enough, you will round out your voltage supply, and that's what it was measuring down here. And in this case, let's actually go down to roughly around where our battery voltage is, 3.2. And I'm going to just touch the lead here to this here. You see it's about same brightness. But if I increase, this is just difficult to do. Yeah, an extra set of hands would be very helpful. So just keep this within the range of the shot and just hold it. And you can see, yeah, it's not the easiest to clip on there. You can see that's about where our current that we measured earlier was. But if we increase the voltage to 4.1, it goes up a little. And we increase it all up to 5, it goes up a bit more. But you can see there's not that much change. And this is these lamp bulbs that I've sent you guys can go up to 6.5 volts, if I recall correctly. They can't accept higher, but they're just designed for that voltage. So you can see now, I don't know how well you can see it on the camera, but the voltage, the bulb itself is now very bright as opposed to whenever it was down here at 3 volts. But what happens if we go lower? Well, the voltage sticks around 10, as we're at 2 volts here. And then 7, and it kind of, goes a bit, almost a little bit linear as you're lower down, even though there's no light coming out. But if we increase the voltage, it steadily goes up. as we increase, up until it actually starts glowing, and then you see the current starts having that logarithmic, that little curve that I had showed earlier, as opposed to the linear one, where it starts leveling off at what the max current is, very slowly. And so I again implore you to go through and record all these measurements and actually give a map out that curve and see what it's like. Yeah, that's how you use a power supply, and that's more or less how this activity goes. If you have any questions, please don't let me know.
And I'll just add real quick, you know, anytime you have those exposed wires connected using the alligator clips or banana clips, I would highly recommend putting a piece of tape around those exposed wires, because it's inevitable that you're going to sit there and you're going to be moving stuff around or something's not going to connect right, and then you end up shorting 2 wires. And in particular with the power supply, if you do not have the current limit set up and you have high current, then all of a sudden these 2 wires are going to short. They're going to cause a lot of current to flow. And so it can certainly damage something, and it'll spark. It's kind of freaks you out when it happens too. So please be careful with that. Just make sure, I always like to check those current limits on the power supply and make sure that it's not set too high before I start you know, turning things on. So turn on the power supply first, check all the currents of the current limit as well as the voltage, the max voltage that you want, and make sure you're not increasing, have those things set incorrectly when you're first powering on a circuit.